Okay. Hello students, in today's class we are going to discuss the dynamics of rotational motion. So we have already seen the kinematics of rotational motion in the previous session. There we have seen the terms related to linear motion and the term related to the rotational motion. So in the same way here also we are going to see the terms related to the linear motion and the terms related to, that is of course physical terms we are speaking, physical quantities, I can say physical quantities related to the linear motion and the physical quantities related to the rotational motion under dynamics. So first I'll write the concepts or the formulae for the linear motion, and accordingly we try to change their respective terms, and we try to write the respective terms in dynamics for rolling motion. So here the heading we can go for dynamics of rolling rotational motion. So as I said, in today's session we are going to discuss the dynamics of rotational motion. So what do you mean by the dynamics? Dynamics means here we consider the force also. What is this force? The cause of motion. In kinematics, we don't consider any cause of motion. And we have seen the equations, how to write the equations of motion in kinematics of linear motion and kinematics of rotational motion. Now, in the same way, here also we write the equations for dynamics, both for linear motion as well as for rotational motion. So the first equation, what I'm giving you as an example, is for the momentum. Momentum, what is momentum, students? Momentum is nothing but the product of mass and velocity. And the definition for momentum, you know, it is the quantity of motion contained in the body. Quantity of motion contained in the body is called as a momentum. So students, here also I stress on my statement, don't try to learn the formula of this rotational motion, or I say the dynamics of the rotational motion. Try to understand the concept and try to write the formula by yourself, or try to frame the formula by yourself. The hint or the trick what I am showing you is very important here. So here you can see the first one. Suppose I take the linear momentum. So for the linear momentum, what I write, P is equals to mv. This is for linear motion. I'm writing all the quantities here for linear motion. There, analogous terms, there I'm writing for rotational motion. So here we write for rotational motion. This is for rotational motion. Now here we speak about the linear motion because of the linear quantities we are discussing linear motion में. अब यहाँ पे linear momentum लिए बेटा, तो यहाँ पे हम लेंगे angular momentum or rotational momentum also, you can say angular momentum. Angular momentum, we denote this angular momentum by L, that is equal to, pay attention, what is this mass? Mass is the inertia, is the measure of inertia. But here in rotational motion, we don't consider mass, we consider moment of inertia. That means in place of m, you have to write I. I repeat once again, here in linear motion, we say the mass. And here in rotational motion, we speak about the word or the physical quantity, that is moment of inertia. So m is replaced by I here. So therefore, I take here I. And this is what this is the linear velocity. So therefore, here I will write as angular velocity. I hope you have understood. Next, we move to the second one. Here we speak about the force. In linear motion, we speak about the force. What is the formula for force? Force, F is equals to ma. This is one relation what we have, F is equals to ma. Another relation also we write, F is equals to dp by dt. That is rate of change of momentum is a force, or F is equals to ma. These two relations we have seen already in linear motion. So let us write the similar physical quantities what we are going to use in rotational motion. In linear motion, students, we always speak about the physical quantity force, that is the cause of motion. But here in rotational motion, we don't speak about the force. Here we speak about the turning effect of force, that is what you call it as the torque. I repeat, in rotational motion, we don't speak about, or we don't consider force, we have to consider the turning effect of force, that is torque. So accordingly, we write the formula for torque in rotational motion. So this is the force, and here what I say here, torque, and we denote torque by the symbol tau. The symbol is tau. And here you can see it is mass. Mass is to be replaced by moment of inertia. And this is an acceleration, linear acceleration. Here we write about the angular acceleration alpha, angular acceleration alpha. Now students, here the second formula, again, tau is equals to, this is dp by dt, where p is the momentum. Here we speak about the angular momentum. So the same formula we can write dl by dt also. This is for the torque. The third one I am writing. We can go for work. Work. What is work? Work is the product of force and displacement. Force and displacement when both are acting in the same direction. Okay. So for product of force and displacement, we call it as work. But in this rotational motion, that is also a work. But how to frame the formula for work under this situation? Let us see. So here work, we write for work, that is W, and W is equals to, this is force, right? So in place of force, already I told you, here we speak about the force, and there we speak about the term torque. So therefore here I will write torque, and this is the linear displacement we write here for angular displacement. Now students, let us move for the fourth one, that is kinetic energy. Kinetic energy. Students, this kinetic energy, if you speak, so we write the formula for kinetic energy as half mv square. Half mv square. This is the one formula for for kinetic energy. Another formula is what? P square by 2m. This is momentum by 2m. P, momentum is square by 2m. This is also the formula for kinetic energy. The same I can write here also. That is here also what we speak, rotational kinetic energy. Rotational kinetic energy, and that we write it as half mv square. So here it is half I omega square. What is the reason for writing? Mass is I'm replacing by I, linear velocity I'm replacing by angular velocity. The next formula, P, it is the momentum. But here we speak about the word momentum, linear momentum, there angular momentum, and that we denote it by L. L. So therefore the formula, second formula will become as L square by 2 into, this is mass, that is I, moment of inertia. So therefore L square by 2I. That's the formula for rotational kinetic energy. Now next move for power. Power. What is the formula for instantaneous power? Power is force into velocity, that we have already seen. Product of force and velocity gives us the instantaneous power. So the same formula we can write there as, this is the rotational power. This is power. Power is equals to, that is P only. We denote it by P only. This is force, that is torque. And this is velocity, and we replace it by angular velocity. So therefore, this is tau, and this is omega. So in this way, students, without remembering the formula for the rotational motion or of dynamic, rotational motion of dynamics, or in dynamics, I can say, so without remembering the complete equations, just if you know the equations for linear motion, you can write 100% correctly the equations for rotational motion. I hope you have understood how to write the physical quantities related to dynamics of rotational motion. Students, we are looking for a problem which is on the dynamics of rotational motion. The problem here, you can see the instantaneous power we need to calculate for a rotating wheel with an angular velocity of 20 radians per second. Therefore, I am writing omega as 20 radians per second. And when a torque of 10 Newton meter, torque is also given, this is 10 Newton meter. so is applied on it. Our question, our aim is to calculate what the instantaneous power. So what is this instantaneous power? You know, it is the product of force and velocity. So therefore, what I do here is I think for the equations of linear motion and we write the same thing for rotational motion. Power is equals to Fv, but here we write power is equal to torque into angular velocity. So therefore, what is this torque? It is 10 and angular velocity is 20. So therefore, we can write this as 200. And you can see, student, this is 200. 10 into 20, 200. What are the units? The units for power. क्या हो सकता है बेटा यहाँ पे power? So यहाँ पे हम लिखेंगे watts. I hope you have understood the complete concept or the complete question here. I can say the complete question along with the solution what I have done on the board. The next problem, what we are going to discuss based on the same concept here, compute the angular acceleration of a wheel having moment of inertia 20. So here, moment of inertia, it is how much? 20 kg per square meter. When a torque of 10 Newton meter is applied on the wheel. So here torque is also given. Torque is how much here? This is 10 Newton meter. So we have to calculate the angular acceleration, and we know the angular acceleration, we denote it by alpha. It is the rate of change of angular velocity. That only we are going to write here. So this is angular acceleration alpha. It is how much? So what is the relationship that exists between these three? That is very important for rotational motion. So if you don't remember also, no need to worry about this. This is something like mass, right? Try to understand it, students. I'm writing here for your understanding. This is mass or related term here, F, right? And alpha is the angular acceleration. Here we take it as linear acceleration in linear motion. So what is the formula that relates all these three physical quantities? F is equals to ma is the best relation, that is Newton's second law of motion. So F is equal to ma. We write here F is equals to ma, and the same we can write for this rotational motion as tau is equals to I alpha. Tau is equals to I alpha. Hope you have understood the framing of the formula. So what is this alpha? Alpha is nothing but tau by I. And what is this tau, student? This is 10 by I is how much? 20. So therefore it is 1 by 2. This can be written as 0.5 and radians per square second. Students, let us see the next question on the same concept. Here a uniform rod is there of mass m and length L. The length L it is suspended by two strings at its ends as shown. The diagram I am going to show you. When one of the string is cut, the rod starts falling with an initial angular acceleration. So let us see. This is I can say the most important question of this topic is this one, or the most important question. Most मतलब बहुत ज़्यादा important है बेटा. आज हम जो topic पढ़ रहे हैं, that is dynamics of rotational motion. This is the one of the most important questions for that. So here what we are having, try to understand here. This is the diagram. This diagram is mentioned in the question. This is a rod. One rod is there, uniform rod, and mass is how much m. Length of the rod is L. And it is suspended by the two strings. This is one string, this is another string as shown. So this is the diagram given in the question. Now, when one of the string is cut, the rod starts falling with an initial acceleration. So what we are doing, students, here, यहाँ पे हम बेटा यहाँ पे इस तरह से कट कर दिए. So as soon as इस string को हम कट करते हैं, तो what happens, it will not fall down. It will start rotating like this. इस तरह से rotate होगा because one of the end is fixed. इट इज नॉट लाइक दोनों एंड्स हम नहीं कट करें, सिर्फ एक ही एंड हम कट करें. तो यहां से क्या होगा बेटा, ये इस तरह से फॉल होगा. सो इट इज नॉट फॉलिंग, मतलब इन द सेंस इट इज रोटेटिंग. सो रोटेशनल एक्सेलरेशन की बात कर रहे हैं. दैट्स व्हाई वी आर स्पीकिंग अबाउट एंगुलर एक्सेलरेशन. आई होप यू हैव अंडरस्टूड द क्वेश्चन. सो यहाँ पे हम देखेंगे हाउ इट इज. सो यहाँ पे देखिए बेटा, व्हेन इट इज टर्निंग, सो वी हैव टू टेक द टर्निंग इफेक्ट. दैट इज व्हाट यू कॉल इट एज torque. The concept of torque you have to take. We have the two formulae for torque. One of the formula what I have shown you, that is I into alpha, that is I alpha, right? This already I have shown you just now. Force is equals to mass into acceleration, torque is equals to moment of inertia into angular acceleration. This we have seen. Now, at the time of defining the torque, I said clearly torque is the turning effect of force. Turning effect of force, and it is measured by the product of force and the perpendicular distance. I repeat once again, the formula for torque is the product of force into perpendicular distance, or perpendicular distance into force also you can take. So another formula for torque is, what I do here is force into perpendicular distance. This is the fun of the formula what we can use. This is the torque, this is also a torque, both are the torques acting on the same body. So I take, what I do, you know, दोनों भी ये torque है ना बेटे, तो दोनों को हम एक साथ equate कर देंगे हम. This is force into, this is the sign for perpendicular distance. Now pay attention, this is a very very important question I am reminding again. Now students, when it is falling down, when it is rotating, what is the reason for this to come down? The reason here is because of the weight of the rod. So here you can see the force acting on the rod itself is nothing but the weight mg. Weight mg की तरफ से ये नीचे आ रहा है बेटा. So therefore the force acting is how much? mg. तो यहाँ पे मैं क्या लिखता हूँ? The force is mg, and from this end, because it is rotating like this, so from this end, what is the perpendicular distance of this force? Because the total length is L, this distance will be L by 2. This distance यहां से लेके यहां तक बेटा कितना distance होगा? Just L by 2. So force तो हम ले रहे हैं mg, but how much is the perpendicular distance for that force? It is L by 2. So this perpendicular distance I will take it as L by 2. Now students, come to the other hand. This is what I is the moment of inertia. And you know how the rod is rotating? Is it the rod rotating from the midpoint, or the rod is rotating from one end of its, from one of the ends? So you can see clearly when you are cutting the string, this rod is rotating about one of its end. So I have given you the formula, that is we have derived also, that for the midpoint it is ml square by 12, but the rod is not rotating from the midpoint, the rod is rotating about one of its end. So therefore we have to take it as ml square by 3. So here I take I as ml square by 3, and this is alpha. Now let us simplify it. M get cancelled, 1 L get cancelled. So it is L alpha by 3 is equals to G by 2. So alpha is equals to, just cross multiply, it is 3G by, this is 2L. So this is the initial angular acceleration of the rod with which it starts going to rotate. Now students, let us move to the next problem. The next problem here you can see the angular momentum of a body changes by, angular momentum is changing by 80 kg square meter per second. So angular momentum is changing, okay, when its angular velocity changes from 20 radians per second to 40 radians per second. Again, it's written as 2 times, but it is only one. This is and the extra part what we got it by, it is a typing mistake. So find the change in the kinetic energy of rotation. So what is this kinetic change in the kinetic energy? Change means, what do you mean by change? Change means final kinetic energy minus initial kinetic energy, or I can say the difference in the kinetic energy. I repeat, beta, difference in the kinetic energy is the change in the kinetic energy. So I'll take, see, change in kinetic energy. This is what I can say, the difference in the kinetic energy, final kinetic energy minus initial kinetic energy. But kinetic energy formula, again the question arises, what is the kinetic energy for rotational motion? So we know for linear motion half mv square, m we have to replace it by I, and we have to replace it by omega. So therefore what I do here is, this is final, I am writing half I omega 2 square minus half I omega 1 square. So this is the difference in the kinetic energy of rotation. Now students, The question what they have mentioned is the angular momentum is changing. You can see clearly angular momentum is changing by 80. So let us move with this first, then again we can come to the actual question. So here I'll write the part here. Angular momentum means what? L2 minus L1. So what is this L2 minus L1? How the angular momentum is changing? By 80. And we know the formula for angular momentum, it is I omega. I omega. So therefore, this I will write it as I omega 2 minus I omega 1, that is equals to 80. So this term I omega 2 minus I omega 1, they have mentioned it as 80 as per the question. And you can see clearly the angular velocity changes from 20 to 40. 20 to 40 means omega 1 is 20, omega 2 is 40. So let us move with the problem. Now, come. This what I can do here is 1 by 2. This you can see students, I can take common. So if I take I common, what I am going to get here? Omega 2 square minus omega 1 square. This is 1 by 2. This is I. This is something like a square minus b square. So we can write a plus b into a minus b. So here what I do here is omega 2 plus omega 1 into omega 2 minus omega 1. I hope you have understood. There's something like a square minus b square. So a plus b into a minus b. So what I am doing is, students, I am writing this term first. This just for the arrangement for your understanding. This term I am writing first, omega 2 minus omega 1 into this term next, omega 2 plus omega 1. Now, students, from this relation, if I take I common, what I am getting? Pay attention. If I take I common, this is nothing but omega 2 minus omega 1, and that is equals to 80 units. Just I am taking I common. So I omega 2 minus omega 1, that is equals to 80, right? So here also I am getting the same term here, I omega 2 minus omega 1. So what I do here, in place of this, I will write it as 80 into omega 2. What is omega 2, students? Omega 2 is our final angular velocity, that is 40, and initial angular velocity is 20. So therefore here I'll write 40 plus 20. 40 plus 20. So this is one time, this is 40 to 400. Now pay attention, this is the kinetic energy, change in kinetic energy. So change in kinetic energy, it's a unit for kinetic energy. So therefore I will write here joule. I hope you have understood the question along with the solution part.